This is video lecture number 2 of week 1. In this video lecture, we start the topic number 1, limit and continuity. Let us first understand what do you mean by limit and how we find the limits numerically and graphically. So, to understand the concept of a limit, we take one example. Let's see this example. What actually we are asked to do here? We are asked to evaluate, that means find the limit of this function. Look at it. What is this function? Look at the numerator. This is quadratic function, polynomial. This is the linear, and we divide it. That means it is a rational function. That is, we are finding the limit of a rational function as x arrow 2. That means x approaching 2. It is not x is equal to 2. It is x close to 2. So the question is here, what is the limit of this function when x is close to 2? That is, what is the value of this function when x is close to 2? So if you check the coordinate system, when I say x close to 2, that means this is 2. And when I'm going close to 2, there are two ways of approaching this 2. One is from the left side and another is from the right side. When I come from the left hand side, all the values of x are less than 2. When I approach from the right side, all the values are greater than 2. So don't forget, you should be close to 2, not far away. That means you come from the left and come from the right, but because in both ways you're coming to this value of 2. And check here, this x is represented on the x-axis, and what is represented on the y-axis? The y-axis is represented by this value of the function, that is fx. That means y is on the y-axis. That means we are finding the limit of this. That means we are checking the answer here, and this the values of x are given to you. So the x value approaching given, the function is given, and we are finding what is the value of x along the y-axis. So therefore, we need to prepare the table here for x coming from the left. See, x 1.9, 1.99, and all that. So all these are your approaching to. And then on the right side, we are approaching from the right side. All values are, you see, 2.1, 2.01, all the small value. So this is, all these values are less than 2. All these values are greater than 2. That means this from the left side, you're approaching 2, and this from the right side, you're approaching 2. So what we do here is we prepare this table to find for the values of x less than 2, what are the values of y? That means what are the values of fx? That means these value has to be substituted in the function, and we need to obtain the values. And the values has been obtained. Please check with your calculator. So substitute these values and find the values of fx here. When you see this table, what we see here is that you just see, notice as you move down the first column of the table, that is, you see, first column of the table, you move down, the x values get closer to 2. You see, 1.9, 1.9 is closer to 2. But are all less than 2? All these are less than 2. So For this, we use the notation x tending to 2 to the power minus. Look at it, this is not minus 2, it is just a notation that you're coming, you're approaching 2 from the left side and the values are less than 2. So this notation x tending to 2 to the power minus 1 to indicate that x approaches 2 from the left side. Notice that the table and the graph both suggest that is this table and this graph. Now let us understand the graph now. See, I come from this, right, the x values, and to find the y values you have to follow the graph, right? So when I follow the graph here and I stop at this point, that is at x is equal to 2, I stop it here. So what is happening here is that the table and the graph, this table and this graph suggest that as x gets closer and closer to 2, that is with x is less than 2, fx is getting closer and closer to 4. You see 3.999 closer to 2, and you see when the graphically also you are going to put 2. What is this open circle? Open circle means when x is equal to 2, fx is not defined, right? If it is filled circle, so when x is equal to 2, fx is defined. So here, when x is equal to 2, fx is not defined, but when x is approaching 2 from the left hand side, fx is approaching 4. Means limit value is 4, the actual value of the function is not defined. So we write here the limit of fx as x approaches 2 from the left is equal to 4. So we write symbolically like this: limit of fx as x tending to 2 to the power minus 1 is equal to 4. So remember that this 2 to the power minus 1 is just a symbol, it is not minus 2. You need to write minus in the power up, not left side or down, right? So similarly, we use the notation x tending to 2 plus to indicate this table, to indicate that x approaches 2 from the right side, and we compute some of these values in the second table. Again, the table and the graph, you see this table and the graph, you see now what is happening here is we are approaching these 2 from the right side, right? And I have to follow the graph from here, and it is going to what? 4. So means the graph both suggest that x gets closer and closer to 2. With x greater than 2, fx is getting closer and closer to 4. So we say that limit of fx as x approaches 2 from the right is 4. So we write symbolically limit of fx as x tending to 2 plus is equal to 4. So this and this are called one-sided limits. And since the two one-sided limit of fx are the same, see 4 and 4 they are same. So we say that the limit of fx as x tending to 2 without plus minus is 4. So this is the limit, this is the right hand limit, and this is the left hand limit. This and this one-sided limit, but this is just a limit. Let's take one more example where the limit does not exist. Now look at it. In this case, the limit exists because you get a real number 4, and whenever you find uh, a limit which is a real number, you can say that limit exists. So let's say when the limit does not exist. Another example. This time, again I am taking the rational function 3x plus 9 divided by x square minus 1, and then we find the limit of this function as x tending to 3, that is close to 3, right? So let's see, determine whether the limit exists or not. So for the same, what we call the way how we have done here, that is we prepared the two table close to 2, that is less than and greater than 2. Exactly in the similar way we have, see, close to 3 from the right side, this is from the left side. So you see here the graph, the first graph, first table. When x is, you're giving the values 3.1, that is close to 3. What is happening here? From the right side, when you're getting the values of the function becomes 30, and suddenly it jumps, it is increases, and suddenly it increases, and it is goes on increasing drastically. That means the value of fx are increasing without any limit. That means they are going to infinity, that is plus infinity. When you therefore, and here you see this example. Now you see we have a 3 here, and you're coming from the right side, and see how the graph, there is this graph comes here, and it is not what we call giving you any value of y. That means this goes and goes on. So that means based on the numerical, that is this, and graphical evidence, that is right side, it appears that x tending to 3 plus, this function is increasing without bound. So whenever you have increasing without bound, then immediately you have to say that the limit does not exist. Similarly, the graph and the table for the values less than 3. So look at this graph. When x is 2.9 minus 30, 99, suddenly it increases, and all are increasing. And here what happened here is it is decreasing. In this case, it is increasing without bond. So in this case, it is decreasing without bond because of the minus. So therefore, we say that the limit of this as extending to 3 to the power minus does not exist. So graphically also you see, I come from this to 3, you see how the graph behaves like this, goes on increasing. So therefore, this goes on decreasing. So that's the reason that you see this graph and this table, I can see this. So right hand limit does not exist, left hand limit does not exist, definitely the limit does not exist. So you have to be very careful that limit exists means you get a real number. Limit does not exist means increasing without bound, decreasing without bound. So this is how we find the limit of a function using table or using numerically finding the limit. This is the first type of questions, the topic number 1 here in the limit and continuity. So let's see the definition here. A limit exists if and only if both corresponding one-sided limit exist. So for a limit to exist, one-sided limit must exist, right? And not only that, both the one-sided limit must be equal. See, left hand limit, the limit exists. See, we have L, this right hand limit L, both are equal, therefore this limit. In other words, I can say that here When I say limit of fx as x tending to a is L, that means we can make fx close to L as we want when x is sufficiently close to a from both the side, but it is not equal to 1. So we now consider exact definition of right hand limit, short form RHL, left hand limit, short form LHL. If the value of fx can be made as close to L by taking the value of x sufficiently close to a but always greater than a, then we write like this, which is known as a right hand limit. That is, limit of fx as x approaches a from the right is L. If the value of fx can be made as close to L by taking the value of x sufficiently close to a but always less than a, then we say that the limit of fx as x tending to a minus is equal to L. So the limit of fx as x approaches a from the left is L. If both the statements are true, that means limit exists, and they are equal, then we say that limit of fx as x tending to a L without positive negative here, positive for left hand limit, negative for left, positive for right hand limit, and negative for left hand limit. In summing up all, so we can write, we can finally define the limit is if the values of fx can be made as close as possible to the some value of L by taking the value of x as close as possible but not equal to a, then we write limit of fx as x tending to a is L. That means this particular definition can be understood by this example, the first example which I discussed. You see that fx we can make close to 4 when x is close to 2. Fx, if x is not close to 2, then fx is not close to 4. If x is away from 2, then fx is away from 4. When x is very close to 2, then fx is very close to 4. So that means if I can make fx close to 4 when as x is close to 2, then I say that the limit exists. So you have to be very careful that the limit value and the actual value are two different things, not to be get confused. In some cases, the limit exists, the value doesn't exist. In some cases, the limit also exists, the value also exists, and in some cases, the value and the limit exist, both are equal. So you have to, and in some cases, left hand limit exists, right hand limit exists, but they may not be equal. So you have to be very careful about all these and concept here. So that's all about the what you call about the limit. Now, what we have done in these two examples, that is in this example 2.1 and then example 2.5, we found the limit numerically, that is by preparing the table. Now what we do, we now find the limit using the graphs. So how we do here, how the question will be given here, the whenever you are asked to find the limit graphically, the functions will not be given. You will be given the graph, and look by looking closely at the graph, we are going to determine the limits. So we are determining limit graphically. Here the function is not given. Let's see this example 2.3. Use the graph in figure 1.8. This graph determine limit of fx as x tending to 1 minus limit of fx as x tending to 1 plus limit of fx x tending to 1 and limit of fx as x tending to minus 1. So let us find one by one. For the first one, that is limit of fx as x tending to 1 minus means we are here, right? And then you are approaching from the left side. We consider y values. That means we need to find y values because limit value is always on the y axis. We find y value as x gets closer to 1 with x less than 1. That means we are coming from the left side. To find the y value, I have to move along the graph. You see, observe the graph where it ends into the open, where it ends. For example, you see here, now we are here, right? And I'm approaching from here. So to find the limit value, I have to move along the graph from the left side and where it ends here. What is the coordinate of this point? It ends with 1 comma 2, that is x is equal to 1 and it ends with 2. So therefore I say that limit of fx as x tending to 1 minus is equal to 2. So please note here the limit value is 2, but when x is equal to 1, the value of the fx is not defined because we have an open circle here. So look at it. Open circle is for finding the value of the function but not for finding the limit of a function. Look at it. Limit of fx exists, which is equal to 2. The value of the function does not exist. Means limit of a function is equal to 2, then fx when x is equal to 1 is not equal to 2. That means it is not given here. That means because of the open circle, it is not defined. Let's see the second part. Limit of fx as x tending to 1 plus. We follow the graph towards x is equal to 1. This time from the right side, that is x greater than 10. And let's check where the graph dead ends. So I come here we have, and now I come from the left hand side, then I will follow this part of the graph. When I follow this part of the graph, we get a point 1 comma minus 1. So therefore I say that the limit of fx as x tending to 1 plus is equal to minus 1. So what is the limit value? Minus 1. What is the actual value? That means what is the value of fx when x is equal to 1? It is minus 1. Why? Because it is a filled circle. So in the first case, limit exists, value of the function doesn't exist. In the second case, limit exists and the value of the function also exists. Limit value is minus 1, value of the function is minus 1. Limit of the function here is 2. The value of the function does not exist. So you have to be very, very careful in distinguishing value of the function, limit of a function. Value of the function means equal to the value. The limit of a function means close to that value. Now to find the third one, that is the limit of fx as x tending to 1. This is not one-sided limit. So for this I need left limit and the right limit. They are in fact this and this. We found the first limit as 2, that is left hand limit, and then we have found the right hand limit is equal to -1, and they are not equal. Therefore, we say that limit of fx as x tending to 1 does not exist. Similarly, to find the limit of this, I am approaching -1. So this is not a one-sided limit. So to find this limit, I need to find left one-sided limit, that is the left limit and the right limit. That means we are here. Fine. I come from the left hand side, right hand left hand limit, right come from the right hand side, left hand limit. You see that the left hand limit, you see how the graph it is coming here, and you're getting 1. So left hand limit is equal to 1 for x tending to -1 power -1. Right hand limit, that is limit of fx as x tending to -1 plus it is also 1. So is it the value of the function at x is equal to 1 defined? Yes, because of filled circle, no open circle. So left hand limit is 1, right hand limit is 1, value of the function is 1, and since the left hand limit and the right hand limit exist and equal, so we say that limit of fx as x tending to -1 is also. So this is a very important example. In fact, in this part of uh, lecture, we are basically uh, working two types of questions. One, finding the limit numerically, and finding the limit graphically. So this is an example for that. So we now come to exercise 1.2 in the textbook, pages 75 and 76. Here we are dealing with two set of questions. In the first set of question 1 to 6, we use numerical method to find the limit exists or not. That means, see the same. For this 6 question, we are going to evaluate the limit numerically. Means to solve these 6 questions, you need to just take this, do the same way 2.1 and use 2.5. But here in this question, here in this, you need not draw the graph. Okay, so try this, and I will give you some more idea in the live class. This is the first set of question where we are finding the limit numerically. So 6 questions are there. Just try this and get me the answer or give me the answer, and I will tell you exactly whether it is correct or wrong. But you need to work out, okay? And you need not prepare a huge table. A small 3 to 5 values will give you the idea about the limit. Second set of questions are this question number 7 and 8. So only we have to identify whether the limit exists or not. So the graph is given. So graphically we are finding no fx. So the graph is given here, and we are asked to find the limit exists or not. Let's see 7a. Limit of fx as x tending to 0 minus. That means you are here and you are now coming from the left hand side. Okay, then I have to move along the graph, right, till I end with 0. So what happens? The limit of fx as x tending to minus 0 minus is equal to -2. So the limit value is -2 in the first case, 7a. So do you say that the value of the function is defined at x is equal to 0? Yes, because there is no open circle here. So f of 0 is 0. yeah, sorry, f of 0 is minus 2. That is, fx is minus 2 when x is equal to 0. When I say x is equal to, it is the value of the function. Okay, so not the limit value. Let us consider limit of fx as x tending to 0 plus. That means I am coming from the right side. So 0 is here, I come from the right side. That means I will follow this graph, right? When I follow this graph, it is going ending with 2. So therefore, the limit of fx as x tending to 0 plus is 2. So the answer for 7b is 2. So limit exists and it is equal to 2. So is it the value of the function exists? No. That means fx does not exist when x equal to 0 because of the open circle. Okay. So C, find the limit of fx as x tending to 0. So this is not a one-sided limit. So for this, I need to find a one-sided limit, that is 0 minus 0 plus, which we already found here. In the first case, it is minus 2. The second case, it is plus 2. And limit exists, but they are not equal. Therefore, this limit does not exist. So that is how we need to what to call address. I mean, solve this question. And for solving 7 and 8, you are using this question example 2.3. So what we learned in video lecture number 2 of the week 1, we understood. We started the first topic, that is limit and continuity, and first, we understood what do you mean by a limit. Not only that, we understood clearly what is a limit and what is one-sided limit. That is, what do you mean by left-hand limit and the right-hand limit? And when the limit exists, as I told you, the limit exists whenever you get a real number. And when the limit does not exist, that means the limit does not exist if you get plus infinity or minus infinity. So, so we that is very clear here. And finally, we uh, understood the method of finding the limit numerically, that is using table, and graphically, that is using only graph, no function. So here function given, here graph given, and we find it. I mean, we are finding the limit accordingly. So that's all. Thank you, one and all.